Hey everybody, this video is going to be titled Chemical Reactions Part 1. The unit on chemical reactions has a lot of different information that we need to go through, so it's going to take me more than one video because I want to try to keep them short. This video should be watched as we have posted online. This is what you're watching Wednesday night on January 16th, 2020. Part 2, I hope to get finished either Wednesday or Thursday, and you'll watch that sometime over the weekend. I know I've told you we're trying to keep from having you to do homework over the weekend, but like I said, this chemical reactions, I don't want you to have to watch a 35 or 40-minute video. That's just ridiculous. So this first one, called Chemical Reactions Part 1, should be pretty easy to get through. I'm hoping it's about 15 minutes long. What we're going to do is I'm going to show you 4 what we would call essential questions for you, those of you in Avid. The 4 essential questions that you need to know in order to do all of this stuff on chemical reactions. So the problem is I can't find my whiteboard pen. There it is. Okay, that was weird. All right, so chemical reactions part 1, the questions we're looking at. First, what happens during a chemical reaction? Hopefully the light is better so you can actually see the words on the board. You don't need to see me. It's not that important. So first question, what happens during a chemical reaction? So we've kind of talked a little bit at the beginning of the year about the difference between a chemical reaction and a physical change. So we need to know what's happening. How do we know that something's taking place? How does a chemical reaction occur? Second question is, how can we describe what's taking place in the reaction? How can we show people when these things come together, that is what's happening? Third, what evidence of a reaction will we have available? This question will not be answered today. This will be in part 2. And also this next question will also be in part 2. Is, are there patterns to help us predict the results of a reaction? What can we do to look at what we have as reactants and figure out what's going to be made? These 2 parts, questions 3 and 4, we will answer in our next video, which will be, like I said, to watch either Friday night, for Saturday, Sunday, something like that, depending upon what happens in class, both Wednesday and Thursday in class. All right, so we're going to put this back up so we can see here. So again, our question was, what happens during a chemical reaction? So hopefully you have a little bit of an understanding that when a chemical reaction occurs, we are making new substances. Chemicals are not remaining the same thing. There's going to be a change in the way that they occur because bonds, something that is holding those molecules together, have to be broken apart, and then new bonds are being formed. This is where the energy of chemical reactions occurs, that there has to be a little bit of energy going in order to break these bonds. So when an endothermic process, we have to put a lot more energy in to break bonds, and then the bonds that are being reformed just releases a little bit of energy, and it takes more energy to break bonds than it does to reform new ones. On an exothermic reaction, we put a little bit of energy in to start breaking some bonds, but when they form new bonds, there's a lot of energy released that goes out to the system, goes out from the system into the surroundings. So bonds are broken, they're reformed, and we know that these atoms, once they are broken, they get rearranged and we make new things. You don't have the same things you began with. You have to be making new substances. That's part of the definition of a chemical reaction. Finally, if you remember in the law of conservation of mass, we said that atoms cannot be created, nor can they be destroyed during a chemical reaction. So whatever is happening, however many atoms you begin with in a chemical reaction, all of those atoms are still there. They just get rearranged into a different format. So what ends up happening with that is when we write a reaction or we write a chemical equation is what it's called, you may not be able to recognize what's going on. So a chemical, chemical equation is a representation of these substances that are involved. What we end up doing is we write the reactants on the left. There's going to be an arrow that points from left to right, and that arrow is saying there is a change taking place. We began with these reactants on the left, and then something happened, that's the arrow, and it makes products, those things that were produced, are going to be on the right. If we were to list it out like this, let's leave that off for a moment. What we're saying is there are reactants. Here's our reactants. We write all of the reactants down on the left-hand side of our equation. And then this arrow is the thing saying that there's a change taking place. When we start to write this out, or when we start to say it out loud, there are different words that we can use to represent this arrow. That could be the word makes, it could be forms, yields, produces, causes to react and become, any of those types of things. So like the way that our English language works, that's what we're looking at there. So reactants do something to form, to make, to yield these products. So these will be the reactants. We write all their formulas. These are the products. We write all of their formulas. But the problem is we can't create or destroy matter. So remember, if we looked at this chemical reaction, can you see? Okay, good. When we look at this, this is how we make water. Hydrogen, which is a gas, reacts with oxygen, which is a gas. And it is a highly energetic reaction that produces water as a gas. What you will see in chemical equations is we have to label the physical state of matter that those substances have. So a G for gas, you will see an L for liquid, you will see an S for solid, and then you would see AQ, which we'll show you on another page, but I'll write it right now. If you see AQ, that means that thing is aqueous. The substance has been dissolved in water in order to allow the reaction to take place. This is something that you did in the lab in class on Tuesday, right? So this chemical reaction is just showing you here, there's reactants on the left, hydrogens and oxygens over here, right? Over here is the products, the water. This arrow is saying something has happened to change them into this. But if we looked at the law of conservation, notice on the left-hand side we have 2 hydrogen atoms, but on the right-hand side we have 2 hydrogen atoms. We haven't created or destroyed any hydrogens. But with oxygen, there are 2 oxygen atoms here, but there's only 1 oxygen in our water molecule. So something is happening. It looks as if we are destroying an oxygen. We would say that this is called the unbalanced chemical equation. An unbalanced equation you should be able to write from the words. If I tell you the formulas of the substances, if I said something like sodium metal reacts with chlorine gas to produce sodium chloride, you should be able to write an unbalanced chemical equation from those words. I'm not going to make you do that now. This is going to be something that takes practice over time. Over the next couple of weeks, you will get better at doing those types of things. So a couple more examples. In the lab, we started with 2 aqueous solutions. I made you create your own. You took calcium chloride, that was the little round beads, they look like little pellets, and you dissolve them in water to make them aqueous. So all we do is to the right-hand side of the chemical formula, we list what its physical state is. So in this case, it's aqueous, it's dissolved in water. We took calcium chloride dissolved in water, and we took sodium bicarbonate, which is also called baking soda, dissolved in water, and we mixed those together. Those are the things that we began with. Those are our reactants. The reactants didn't stay reactants. And as it reacted inside of the vessel, whether you did it in the Erlenmeyer flask with a balloon, or if you did it in the Ziploc baggie, it produced a gas. And what actually happened, there was more than one product being formed. We had calcium carbonate was formed, and you didn't recognize it probably as it happened, but it didn't dissolve. That was the solid, like it looked chalky, or it stayed, when you tried to clean out the Erlenmeyer flask, it was really hard because it was a solid. We'll talk more about what's going on with that in a couple days, maybe a week or so. It also made sodium chloride, which was salt, but that was still dissolved in the water. You couldn't see that. You didn't recognize that it was there. Another product that you didn't recognize was more water was produced as those things reacted together. It is a liquid, so I use a script L, so the computer uses a weird font. I usually use a script L so you know that's an L, not a 1 or an I or something like that. Water is a script L for a liquid, and it also produced carbon dioxide as a gas. So notice every single one of the different physical states of matter was produced in this reaction. We had a solid, we had a liquid, we had a gas, and we had something remaining aqueous. So again, all of these were our reactants, all of these are the products. And what ends up happening to make it so you can actually see it on the screen is, I shrunk it down, we have aqueous calcium chloride reacting with aqueous sodium bicarbonate to make calcium carbonate, solid calcium carbonate, aqueous sodium chloride, water, and carbon dioxide gas. This would be an unbalanced chemical equation. And as you look at this closely, you should be able to recognize that there's not the same numbers of atoms of all of the elements on both sides. I'll just point it out for you right quick. There's 1 calcium on both sides, that's good. But notice what's going on with chlorine. there's 2 chloride atoms on the left. So again, when I say on the left, we're always referring back to our arrow. There are 2 chloride atoms on the left, and there's only 1 on the right. So did we destroy a chloride atom? That's impossible based on the law of conservation. Also notice there's 1 hydrogen here, but we had 2 hydrogens in the water. Did we all of a sudden just create this random hydrogen atom out of nothing? That is impossible as well. So what we're going to end up doing is we need to figure out how to balance an equation. So in order to balance equations, it makes it so that we start with the right number of particles and we end with the same number of particles. The only thing we can do to balance an equation, you cannot change any of the chemical formulas. I can't change this and say, well, I've got 2 hydrogens, so I need to put you can't insert a number in here. The only thing we can change is what's called the coefficient. The coefficients will always go in front of whatever that substance is in the equation. That number will multiply everything in that chemical by the coefficient that we're putting in front of it. So we're going to go back to our water because that's the easy one to look at. With water, notice we had 2 hydrogens, we had 2 oxygens, 1 oxygen. So in order to balance this, I need to multiply the water by 2 to give me 2 oxygens. Now I have 2 oxygens on the left-hand side of the arrow, and now I have 2 oxygens on the right-hand side of the arrow. The other thing that happened is this 2 is going to multiply the hydrogens. If I now have that many hydrogens on the right, 2 times H2, so that's 4 H's, I need to do the same thing on the left-hand side of my equation. So I'll need to put a 2 in front of that. Typically in chemistry, we don't write the number 1. But right here in this balanced equation, we are assuming that there is 1 oxygen that is being supported. There has to be one if I wrote the chemical formula. So now we use a coefficient of a 1 if you want to make sure that people know that. When you go to do an assignment on Moodle, you must have a positive mark that you are answering the question. If you leave a blank, Moodle will mark it wrong. So in Moodle, you have to write the number 1. But in real life, when we write these, chemists never write the number 1 for a balanced equation. We would say the coefficients are 2, 1, and 2, but we don't actually write down the number 1. That hopefully makes a little bit of sense. When we go to this reaction that we've done before, again, we have calcium on both sides, but we have 2 chlorines, so we're going to need 2 chlorines. If we come down to this longer one that's smaller, I know it's probably kind of hard to see, but bear with me and we'll do what we can. There's 2 chlorides here. I need to put a 2, I need to put a 2 in front of the sodium chloride so that I have 2 Cl's. This number is talking to that Cl, so I need this 2 to multiply that entire formula by 2 so that I now have 2 chloride atoms. There's 2 sodiums once I added that 2. So I need to come back over to this side where I only had 1 sodium, and I need to make a 2 to make sure that there's 2 sodiums. Now, not only did we balance sodium, but it looks like we might have screwed up everything else, right? But look, now we have 2 hydrogens to match the 2 hydrogens that were in the water. That became balanced just by fixing the sodium bicarbonate to go with the sodium chloride. It also multiplied our carbon by 2. But if we look, there was carbon in the calcium carbonate, and there's also 1 carbon in carbon dioxide. So I have 2 carbons on the right-hand side to match the 2 that comes from this coefficient multiplying this value. We also now have 6 oxygens on the left-hand side of our arrow. We have 3 from calcium carbonate, 3. We have 1 from water, so that makes 4. And we have 2 from carbon dioxide, that makes our 6. And now we have a balanced chemical equation. Again, based on what we see, we would realize that there's a 1 in front of the calcium chloride, a 2 here, a 1 in front of the calcium carbonate, a 2 there, a 1 in front of the water, and a 1 in front of the carbon dioxide. If you were to do that on Moodle, you would be expected to write the 1s, not just these values of a 2 in front of them. All right? So again, as we start to look at balancing equations, there it is again. Hopefully you would know how to do this. I forgot that I was going to do it on the next slide. So we'd put 2, 1, 2. That balances that equation. We'd go 1, 2, 1, 2, 1, 1. And that is what it would look like to balance those equations. Balancing equations looks like it's going to be really, really hard. Like, oh my gosh, I don't know what to do. But if you know how to multiply and add, and then you compare, this is like the balance beam of like a teeter-totter. You have to have the same number of atoms on the left as you do on the right for every element present. There's going to be a couple other things that we'll do that are going to help us out. Things with polyatomic ions where we don't have to break those things apart. We're also going to see other things where you might not end up with a whole number. You might need to use a fraction. When you're balancing equations, you're never allowed to use fractions. We'll talk a little bit more about this both in class on Thursday and Friday, and then also in part 2 of the video, I'll go through a couple more samples where you get to see balancing equations with lower or higher values than just 1s and 2s. Again, it becomes, like, I don't want to say it's more complicated, but it is complex. It's going to take a little bit of time for you to figure those things out. So on Thursday and Friday, we're going to do a stations activity. You are going to work within a group. The sad thing is for you, I will choose your groups this time. You're going to learn some information by going from station to station and figuring out what is going on in terms of these balancing equations and chemical reactions, and we'll work through them. We probably won't have enough time to finish all of the stations in class on Thursday. We'll pick up and use some of them on Friday as well. Also on Friday, both the stations will be finished. You'll need to turn something in with your group, and then we will also take a little bit of time for you to work on the Moodle assignments. We'll do everything that we can to make sure you have enough time in class to get those things finished. I realized I said I expected everything to be done by Friday. I don't think that's going to happen because of the amount of things I'm going to have you doing in class. I will give you a little bit more time. We'll probably extend those due dates until Wednesday of next week. There's no school on Monday next week for Martin Luther King Day, so we will pick up on Tuesday and Wednesday of trying to figure out if you need more time to work on those assignments. I hope this helped you with an introduction to chemical reactions. We're looking at balancing equations and how we represent them, and in the future we will look into it a little bit more of those other questions that we posed. Have a great afternoon. We'll see you soon.